Okay, let's look at section 8.3. This section talks about the equivalence relations and the equivalence classes. Right, let's look at the equivalence relations first. Right, so a relation R on set A is called an equivalence relation if R is reflexive, symmetric, and transitive at the same time. Right? So let's look at an example here. Right? We define R to be, let's see, so it's x is related to y if x plus 3y is even. Right? So let's verify all three properties. Right? Is it reflexive? So for all integer x, right? So let's look at the x plus 3 times x, which is equal to 4x, but the 4x is 2 times 2x. So therefore, we know that this is even. So this guy is even. Right? So which means that x is related to itself by this relation. Right? So it is reflexive. Right? We check that. Alright, let's look at the symmetric. So is it symmetric? So we assume that x is related to y by this relation, right? Which means that x plus 3y is even. So that means that there exists some integer k such that x plus 3y can be written as 2 times some integer k, right? Keep that in mind, right? So let's look at the x plus 3y and y plus 3x. Right, since this is just 3y plus y, so that's 4y, right? X plus 3x, so it's 4x, right? Plus, right, it's hard to see. So this is just 4x plus 4y, right? But from here, we can get y plus 3x, which we want to show it's even, is simply 4x plus 4y minus x plus 3y. Right? But the x plus 3y is same as 2k, so this is 4x plus 4y minus 2k, which is 2 times 2x plus 2y minus k, right? Which means that this is even, so therefore, so this implies that, right, y is related to x. So y is related to x by this relation R, right? So which tells you that it's symmetric, right? Right, let's check transitive. So we know that, say, x is related to y, and also y is related to z by this relation, right? So this means that, let's see, there exists some integer k such that x plus 3y can be written as 2 times k. And also, since y is related to z, there must be some integer L such that y plus 3z is equal to 2 times L. Right? Then since we're interested in showing x is related to z, so I'm going to keep x here. So I'm going to just write it as x equals 3k, oh, actually 2k minus 3y, right? Then I'm gonna just keep 3z, so this gives you 3z is equal to 2l minus y. All right, combine these guys together, we can get x plus 3z, which is equal to x is 2k minus 3y, and 3z is 2l minus y, which is going to be 2k plus 2l minus 4y, which is going to be 2 times 2k, oh sorry, 1k plus 1l minus 2y, right? Which tells you that this is even. So therefore, we know that x is related to z by this relation, right? So it is transitive. Therefore, which makes this guy equivalence relation, right? That's it. I hope that this was clear.